Okay, welcome to the lesson library section of this episode. The topic of the episode is how I think about starting API projects with the OpenAI API. I've been doing this for a number of years now in a lot of different situations, and I've created a lot of different things with the API. So I feel pretty confident in my recommendations about tools that I've used and lessons that I've learned, and some philosophies to take into these projects with you to be able to make something successful, especially now that pretty much everybody is working in artificial intelligence, or at least has a strategy for artificial intelligence. This part of the episode is mine. So I'm checking my notes here. The first thing that you're going to want to do is to understand the problem that you're solving, and you're also going to want to understand your information pipeline. These two things might seem obvious, but I think because of the combination of the newness of the large language model technology, as well as the kind of overwhelm of what these models can do and what they can't do, a lot of people never really pause to think about their problem. I've had clients in the past where the best advice that I gave them was, what is it that your business actually does, as opposed to how can you leverage embeddings versus a Mistral versus a GPT-4, and understanding like when to use those things. Those questions are all relatively secondary. It's really understanding what your problem is, because that'll help you create better prompts, and it'll help you create better pipelines. And speaking of pipelines, an information pipeline is basically the black box functionality of what you're trying to do. The idea is to kind of understand where data is coming in from and where it's going out to. And both of these things are, again, non-trivial, even though they look trivial on the surface. One thing that I found that's pretty successful, especially with the more prototypal R&D type projects that people take on with large language model stuff, is to run the MOM test. The MOM test was created by Rob Fitzpatrick in his book titled The MOM Test. And the idea behind the MOM test is that you avoid mentioning your idea. You don't actually tell them the strategy that you're planning on using, because you might not know that strategy yourself. The goal is really just to talk about their life and ask about the specifics of their life in the past, and to just listen to what your client is saying. If you're working on a solo project, this is kind of the same kind of thing, but you want to listen to yourself. What kind of problem are you attempting to solve? Why do you think that now is the time to solve this problem? And why do you think that this particular tool stack is used to solve this problem? So basically, it just helps you validate hypotheticals by focusing on specifics. Next up, you're going to want to think about your tools and your budget. There's a lot of tools out there, especially with the kind of Cambrian explosion of artificial intelligence tools, and to the point of booms and bust cycles. Just because something is popular doesn't mean that things won't be around a few years from now. If anything, it increases the likelihood, but a lot of things are going to perish in the interim. And I think that knowing the differences is more about wisdom than it is about action. So usually one of the advice that I also offer people is that there's no need to rush this kind of stuff. If you feel like you're behind in large language models, or you feel kind of overwhelmed, as I mentioned a few minutes ago, don't worry about it. It's going to continue to be around, and will have a drastic impact on the landscape of technology and human existence. So you're not at any risk of being behind. But looking at the landscape as of the recording of this podcast, usually you can understand your problem from a retrieval or a generation kind of path. Those two tend to intertwine, I've found, in kind of production work, but usually one always overtakes the other. You're either writing a bunch of things and then editing a little bit, or you're fetching a bunch of data and then kind of like slightly opining on it. So being able to understand, what tools and budgets that you're trying to utilize is a really important tactic. And there's things out there like LangChain and Llama Index. There's a lot of open source LLMs out there like Llama 2. I'm just looking at my notes here. Vector databases like Pinecone, Weaviate. And even though I end up using Supabase, so at least a little bit of insider baseball pragmatic talk, when I'm building a lot of projects, I actually tend to go for the technologies that are older and more proven. And there's a reasoning behind that, is that those projects have a longer shelf life automatically. They're going to be able to be more adaptable to future changes because they've seen more things in the past. And you should just kind of use what you're comfortable with. So I usually don't hop on the new model kind of train as much as some other people do, because I feel like it's largely a distraction from the work that I'm trying to accomplish. So if you are looking to start a project that has some longevity, choose boring technology in a field of bleeding edge technology, especially because they balance each other out really well. And yeah, there's some frameworks out there like OpenAgents that I've heard of and Langdroid, but I wouldn't really worry about those. In terms of budgeting, I took down in my notes here that it's important to allocate for startup costs and your emergency fund, while also knowing about burn rate management, funding sources. These are all things that, again, sound obvious, but will play out in numerous ways. And really, I have a story. When I was building Stenography in 2021, I went through a funding round initially, and I actually ended up turning down the money that we were offered, not because I don't think that the business needed it at the time. This was actually before Copilot was even out, GitHub Copilot. But I just felt like, what was the point? Like, the AI was doing most of the work anyway. Like, to this day, most of Stenography's stack is a serverless architecture that pipes through code to the GPT models and then sends it all back in parallel. And the stack hasn't changed in 3 years. So I'm glad that I didn't raise money, because I think it would have mentally locked me into the business as opposed to allowing me to stay flexible while also being able to get the most out of what I was trying to build. Okay, what's next? Generation or retrieval. We kind of just mentioned this. The idea is that you want to understand if your problem that you're solving for is a fetch business or a creation business. And then another question that I think is really important that I ask pretty much all of my clients is, what data are you attempting to cache? I think that this, particularly when it comes to large language models, is key, because large language models do inference and they take a lot of time. And sometimes they stumble upon the right answer that you want to save. So the idea is that you should cache the really good answers, and then you shouldn't be afraid to refetch those as opposed to having to do recomputational work. And I have a quote here from Algorithms to Live By, which is one of my favorite books, which is the optimal cache eviction policy, which is evict whichever item we'll need again longest from now. So the idea is that if you think that something is used quite frequently, never evict it from your cache. And if something is only going to be used a while from now, you should consider evicting it. But there's other cache algorithms too that you can take advantage of, like RIPQ and Panier. So there's, a lot of kind of like techniques that you can use for caching. So yeah, in terms of embeddings versus completion, I say versus, but like you're going to be using both in your projects, but you will, I think, largely find more success with embeddings projects than you will with completion projects. I've been in very few completion projects that work as well as we'd hoped, and I've been in pretty much the opposite, where embeddings overperformed. So I think that the idea of kind of what embeddings do with the way that humans are kind of expecting LLMs to work, it's a better bet. Okay, next up, architecture. Architecture is important. I think we will talk about this again in the philosophy section, but in the pragmatic lesson library section, I use Fast API. There's a number of reasons for this, but the main reason is the addition of function calling and being able to use a Swagger schema in your architecture built in is a huge deal, and it will save you a bunch of time. It'll save you a bunch of headaches. They have pretty good API key management. It's relatively easy to deploy a Fast API app onto Render or DigitalOcean or whatever your website of choice is, and it's really easy for people to get their head around. I haven't met a lot of people who have struggled with understanding how Fast API works. And yeah, as I mentioned, it has Swagger UI, which is the OpenAI schema, which is really great because you can do examples and you can have like a whole documentation built into your kind of thing. For Next.js, I usually use Next.js as a front end. And the reason that I use Next.js is that, I really like their server-side rendering and their static site generation. But more importantly, it's like pretty well supported at this point. Everybody is kind of using Next.js, and they also have a pretty good AI chatbot library. So if you're attempting to build a chatbot, which in this podcast we'll be talking more about GPTs because there's just so much work to do that really building your own UI from scratch is usually kind of a waste of time, I think, especially if you can build an action. So you build a Fast API out as an action to a GPT, and I find that that's a much better and more reliable pattern. But if you do need to build a front end, I would recommend Next.js, and that's where I've had the most luck. But I think that GPTs are going to be much more effective for most use cases. Another front end that I use quite frequently is Discord bots. Discord bots are interesting because they do a lot of the work of kind of like interaction design, and because the chat is going to be back and forth anyway, my commonplace bot, which we talk about in the commentary code section, is built into a Discord bot, and it requires a lot of or it doesn't require anything. It does a lot of work for you. Basically, it handles a lot of user cleaning, calling the API, like doing a bunch of things that you like really don't think about. Text management, how many tokens fit in a window. All of these things can kind of be solved relatively easy with Discord. And then finally, I wanted to talk a little bit about Postgres versus vector databases. I don't know. I get heat for this, but I think vector databases are stupid for most people's purposes. Most people, I don't think, need a vector database. They just think that they do. I think that you can usually get by, especially with like kind of hyper-localized problems where embeddings are the most helpful anyway, with like a pickle file or like a JSON file or Supabase. I use Supabase Postgres in pretty much all of my projects because it just works. It's kind of annoying to set up the function, and it's kind of annoying to do the repeat work over and over, and maybe one day I'll make an abstract library and post it on the internet. But it's just, I found when I use like Weaviate or Pinecone or any of the other kind of vector database libraries, I'm just always really disappointed. Like I just don't have enough data points to necessitate using a vector database. And then when I do, the UX of them is just so bad, or the developer experience is just so bad that I don't really enjoy doing it. So I would err on the side of not using vector databases unless you, again, have a really good reason or you think that you can wing it. One vector database that I think is really good and well priced is Cloudflare's vector database. I've played around with it, especially if you kind of are used to using Cloudflare's architecture, then I think that you'll probably like that database. But for most people, I would just recommend spinning up a table in Supabase and then just writing the same embed code and sending it through the OpenAI API for embeddings endpoints. So anyway, let us kind of wrap up the lessons here by understanding that, again, the idea is that you want to understand your problem, you want to think about your architecture, and then you want to choose reliable tools. So you want to choose tools that you feel confident in, and I think Fast API, Postgres, OpenAI's API have proven their battle-tested capabilities for these types of apps. And if you are going to be using the API and kind of like working with clients in production, I've used these tools to great effect. They don't scale as well as like maybe like the hyper kind of Google big data scale, but if you are at that scale, you're probably not listening to this podcast anyway. And if you are, I mean, you already know what you're planning on doing, right? Like you already probably have a huge Hadoop stack and a big RabbitMQ thing that's like managing a Redis cache that keeps 1,000 Docker containers doing whatever. So this isn't really relevant for that. But I think that, you know, the podcast of the Agentsmith is really understanding the craft of building GPTs and assistants and agents. And to build really good agents, what you need is to get out of your own way. A lot of the time, you need to understand that a lot of the building process actually comes from just building and kind of like choosing good tools at the outset that you can trust to get you from that 0 to 1 state. But we will discuss that more at Philosophy Plaza. Stick around. Hello and welcome to the Philosophy Plaza. As a reminder, the topic that we're talking about in today's podcast is how to start API projects with the OpenAI API. I'm excited to talk a little bit about philosophy here because I think that a lot of API design actually comes down to a person's philosophy. There's a lot of existing patterns that people will kind of leverage from project to project, but really understanding what you're trying to solve and then building an API for that isn't really a computer problem. It's a human problem. So as we said in the lesson library section, where we were focusing more on the realistic, pragmatic setup of your API projects, with the philosophy behind setting up these projects, you're still going to want to do the same thing. You know, I'm looking at my notes here. The first thing that you're going to want to do is understand the problem that's being solved and what your information pipeline is. So when you're first addressing a problem and you're like, I think that I can turn this into a technology, one of the first things that you should start thinking about is simplifying or extremifying your problem to a place that you can really grasp it in your head. This is known as constraint relaxation, and it's basically solving the problem that you wish that you had. From algorithms to live by, it's this idea of adding constraints back into your project when it's appropriate and removing them when it's appropriate. Professor Richard Zuckhauser also talked about this in Maxims for Thinking Analytically. Well, he didn't write the book. Dan Levy wrote the book, but it was a book about Dr. Richard Zuckhauser, where he said, quote, when you are having trouble getting or thinking straight, consider an extreme or simple case. This will give you the insight to move forward. More generally, make a problem as simple as possible without losing its essence, but no simpler. This is actually very hard. This is non-trivial, and I think it takes a lot of trial and error to get to this point where your software is simple, straightforward, and doesn't have too much bloat in its design. These constraint satisfaction kind of situations really involve you understanding, again, not just the problem that you're trying to solve, but the people that you're trying to solve it for. Because a certain set of constraints for one problem might be a different set of constraints if the end user is a different group of people. So being able to understand what exactly you're trying to accomplish with your problem by simplifying it to its base state is less about removing aspects of the problem that are, I would argue redundant and more about understanding the core conflicts at the base of your problem. And as that applies to large language model APIs, that generally are problems of, again, what exactly are our kind of cost bases? How much do we expect to be spending time running inference problems? And how exactly are we going to set up our architecture for generation versus retrieval? And what data are we trying to provide our users with? Next up, generation or retrieval. As I mentioned before, generation is the ability to have the models generate new text, and retrieval is having them use their wherewithal, their knowledge to understand existing text. When I think of a generation problem, I think of a quote from Does Writing Have a Future? Texts are half finished, their signs rushed towards an endpoint, but past a reader who they hope will complete them. If texts are outstretched arms trying optimistically in despair to be taken up by another, this is what the gesture of writing is disposed to do. When I think about this, what really sticks out to me is that text that's written on a page is often looking for a reader to help complete, understand it. And the reason that this is interesting is because one of my first experiences with GPT-3 back in 2020 was first getting my head around the idea of log props. And when I said the cow goes and it would return moo, 100% of the time. But then if I told it right above in the prompt that you're disallowed from saying the word moo, it would come up with something random every time that I ran it. Until eventually, again, I got caught in what I would call a gradient descent and ran the same thing over and over, printed the same thing over and over. So to me, this was kind of a different form of writing. It was writing probabilistically, but it was still using that probability in a way that was waiting for a reader to tell it what the words were that it was trying to create in the first place. This is another quote from the same book, Does Writing Have a Future? True, good, and beautiful texts, that is, concise texts that flow without interruption, are nevertheless contradictory, are works of a creative dialogue between the writer and the publisher. They justify some hope that not all text will be sacrificed to the rising universe of technical images. So the idea here is that technical images are basically computationally written things, copy for ads, purpose writing, menus. The type of writing that engages with an editor and a publisher is the type of writing that's more meant to be persuasive. It's meant to make a claim. When you have GPT, and I mentioned this in the lesson library section as well, I find that GPTs or GPT API projects that succeed are generally retrieval projects as opposed to completion projects. And the reason for that is that the curation layer of successful data is already solved. You already have really high quality data going through the system when you are doing a retrieval problem. If you're doing a generation problem, you're now facing a two-headed dragon of both hoping that the text generated by the model is going to be good or noteworthy, but then you're also dealing with the problem that you need to hire an editor. You need to have someone proofread it. I don't think this is as big of a problem as some people on the internet would let on. I think a lot of people have a lot of bias and guilt towards this idea of a model creating words that they don't like. But the advantage of being an editor is that you can switch your brain more readily between the states of edit mode and create mode using LLM tools and building these APIs. So as it comes to the philosophy of really good products that you're going to build for your users, I would argue that it's very important to understand not only just generation or retrieval, but what are the probabilities of you getting good responses back that actually satisfy the claim that you set out. This isn't a full-on mathematical proof, but it's more how confident are you? What's your confidence interval in the data that's going to come out of the model? Another quote: prolonged data gathering is not uncommonly used as a means of not dealing with a problem.